Well, look at all this stuff. This video is in response to a question that I had. It actually get asked quite frequently, and that is, what is an open port cylinder? I had thought that I'd covered that a bunch of times in a bunch of videos, but realized that when a specific question like that's asked, you'd have to hunt through hours of my videos to get the answer, so that's not fair. And it's also something I need to address. So I figured what I'll do is start doing some of these short videos on just simply terminology, and maybe expand into some subjects like two-stroke basics over time. But for now, I'm going to focus on just terminology. And the video for today is, what is an open port cylinder? The simple answer to that is that is an open port cylinder. And this one here is not. And really what it is, the passages, here's some more aftermarket stuff here we can look at. Here's another open port cylinder. And the characteristic being these grooves right here in the cylinder side that are the passages that allow the mixture from the bottom end of the two-stroke motor to get pushed through the transfers, these slots, to the top end. A closed port cylinder is one of these, where instead of having grooves in the inside of the cylinder, you have effectively cast passages where the fuel air mixture passes through in order to get from the bottom end to the top end. When we talk about transfer port caps, we're talking about this. And what that means is effectively another piece is attached to the cylinder, and that effectively is the outer wall of the passage. I mean, this is a closed port cylinder. You don't see those grooves. You see these passages, but the passage is also contained by those additional metal caps. Most of the X-torqs that are on the market today have that kind of a configuration where you have a closed port with the outer side being created, the shape is being created by these caps. So, open port, closed port, or this is a standard 372 that's been modified, closed port. And there's many different variations on the theme. You know, you have these here. Boy, you could probably hear that rain in the background. It is absolutely just pouring. This cylinder here is the bottom feeder of the chainsaw world, if you listen to people online, because it effectively has two strikes. Not only is it a open port cylinder, it's also a clamshell. And the distinguishing feature of a clamshell is the upper half of the case, or the structure which would hold the main bearings, is actually cast into one piece with the actual cylinder. And the reason why it's the bottom feeder in the enthusiast world is not that they run any worse, it's just it's hard to modify them. It's hard to change the distance from the center line of the crank to the top of the cylinder to increase compression. Here's the other half of that deal, where you have a one-piece plastic injection molded case where the cylinder would sit right down on top of that, and that makes it really easy to manufacture that saw. You have less pieces and therefore less machining to do. And you know, before anyone dismisses this design, it's worked for a long time. It's actually a very reliable design. There's less junctions that have to seal, you know, less parts. So that's open versus closed. And a clamshell design. What does a clamshell mean? I guess I'm putting more terms in here. And while I have your attention, let's just cover a couple of variations on the theme. On the closed port cylinders, for a very long time, they've had designs such as this. And this is where you effectively have two ports, one on each side. Here's the bottom, and right there's the top. And this cylinder here, I don't know if that's... This cylinder here is from a John's Thread 2095. And the reason why I know it's a 2095 and not a 94 is because it's got this decomp hole. And this is actually new old stock. It has never been used. Good intake boot and everything. Around the mid-1990s, Husqvarna introduced this kind of a design right here, and they call that a quad port. And the distinguishing feature of a quad port is instead of having just one passage per side, it's got two. I'll put a little light into this one here too. And this quad port design is typical of the 372 prior to the X-torqs, the 346, the 357 XPs, the 385s, 390s, those series of professional saws had that quad port design. And I guess theoretically what you get out of that kind of a configuration is because you have those two ports. It's not that you're going to get more cross-sectional area, because that's really going to be based on how much area cast into the cylinder, but you allow the designer to have more control on how the charge exits the transfers into the cylinder. And why that matters is they can get a more efficient mix to the mixture, therefore potentially a more efficient burn. And also they can affect how the combustion chamber fills and have more control of that, therefore potentially more control of the scavenging, otherwise flushing out the old exhaust more efficiently and filling it with a new charge. A characteristic of a quad port saw is it's typically going to be a little more fuel efficient, all things being equal, and it might make more horsepower. It's possible, but just basically a more efficient design, just because the engineer has more controls. That's not to say that the older style cylinder that has the two ports, one each side, isn't a strong saw. I mean, Steel made those darn things right up until a few years ago with the MS660, and some of their other models had that same configuration. John's Thread and Husqvarna have had it since the late 60s. You know? I think I've got some old John's Thread cylinders around somewhere. Yeah, look at this one. This is a John's Thread cylinder from probably the late 70s. So that basic configuration has been around for a long time. Very, very effective, obviously. The Husqvarna 266, 268, 272, they all had that two-port, one on each side design, or two transfer port design. Hopefully that gives you a little perspective. Hopefully by now it's pretty obvious what the difference between an open port cylinder and a closed port cylinder is. Now, because of changing regulations and the introduction of government into the chainsaw world, they've made regulations that require even more control of the burn for emissions reasons, and that's why you have these X-torq designs. They're not going to get you any more power. But basically what they've done is they've come up with a way of putting a little slug of air right at the head of the transfer port at the right time, so there's a little air dam between the exhaust charge and the incoming charge, and you get a couple of things there. Obviously the barrier, but also you have more oxygen in the exhaust as it exits to help complete the burn, therefore less, you know, emissions in the exhaust as it exits the engine. Pretty clever design. And the characteristic of an X-torq cylinder is, well, you have to have passages for that air, and they're up here on top on this 372 X-torq, where the intake port's on the bottom. But I don't know if this will show, but there's some passages right here and right there, those two right there. And basically what happens at the right time, the piston goes down and picks up a slug of air in slots alongside the piston. Then when it comes up, it passes over the transfer and deposits that air right there at the right time. And this is an earlier X-torq configuration. Basically, it's a hybrid in my mind. It's trying to make a 372 be an X-torq. So they kind of did the best they could to take that characteristic and blend it into a 372 case. I don't know if you noticed, but look. The cases on the 372s were designed with this in mind. Look how much cross-sectional area you have there. And look how much you have here at the bottom of the cases to help the gas here get into the transfer ports. And then along comes the X-torq, where you can see that brown area right there. Well, that's the section that's open, that's not open on the cylinder. That's the difference in cross-sectional area between the original versions and the X-torqs. I'll let you ponder that one. Oh, by the way, this is a split case configuration where the crankshaft is totally encased in the two halves of the bottom end of the chainsaw. Most pro saws are of this configuration. And here's a cylinder which is going to be typical of the new saws in order to pass regulations. And this one also is going to be a closed port. I don't know if you can see inside there, but there's no grooves. You just got channels. Also has the caps. And interestingly enough, the difference between a 562, which this one is, and the 555 is the 562 has a little deeper cap, so it has a cross-sectional area a little bit larger in the transfers, and that's how Husqvarna kind of alters the power to match the price points. But on these newer cylinders, the entrance to the transfers are up here, right underneath the exhaust, and the gases go right around the exhaust port. And I'll let you speculate on that. Why would they do that? They obviously put a lot of effort to make sure that the fuel-air mixture from the bottom goes right there all around that exhaust port before it enters into the combustion chamber through the closed ports. And here are the entrance ways to the X-torq passages. I think you can see it in there. Those holes right there. I don't know if that's going to come up in the camera. And basically just raw air is going in through those two ports. This is the intake port where the carburetor is. You know, one of the things that I find interesting is how small the carburetor is on a 562 and how good it runs. So, you know, you put all that in the mix, then there's obviously a reason why this kind of configuration works. It must be counterintuitive, because it's not something that, you know, the average two-stroke hack would come up with as an idea, because we spent all our time trying to figure out how to make things cooler and run cooler and open them up and make them bigger and, you know, a more direct path from point A to point B. But obviously the engineers have come up with a way of not only meeting the emissions, but making that 562 run as good, if not better, than any other 60cc saw in history, in my mind. So I think what's happening here is these newer, more complex designs are beginning to push the edge of our understanding as mere hobbyists and hacks. So we started this video talking about open versus closed port cylinders. And then we kind of just very briefly touched on the different case designs to support clamshell versus, you know, a more conventional cylinder. That Husqvarna 350 bottom end, pretty typical of a clamshell design, in concert with that cylinder, where the other half of the case that surrounds the bearings is cast into the cylinder. And your pro saws. Anyway, I hope that's been helpful. And here's one of the case halves for a 2166. Hopefully that was information of use. Well, this is an addendum. I got a bunch of junk laying around. And this poor old maligned cylinder. There's something to be learned from this cylinder right here. I don't know if you realize how many holes are on the intake side of this damn thing. I'm going to count 1, 2, 3, 4, 5, 6. I wonder if we can see from the intake here all that stuff. Now I'll let you ponder this a little bit too. And check out the exhaust on this big old monster. I think they were worried about compression. This is a cylinder from a 1978 KTM 420. It had been stuck and needs to be bored out and a new piston put in and all that stuff. But there's some lessons in this cylinder right here. First, the whole concept of quad port and having a lot of control of how the gases enter into the combustion chamber is not a new concept at all. It's been around for a very, very long time. The second thing is this, not to be a bit of a motorcycle snob, but the saw hot rod guys have been working their way towards this 1970s concept for a very long time. And you see the race saws where they have basically cut the top of the cylinder off to make room for a cylinder head. Well, this is what they use for inspiration, and the reason is when you cut the top off and make a separate cylinder head, then you can actually machine the shape that you want for your combustion chamber. And there's a lot of reasons why that makes sense. One, obviously, is to control the volume, which effectively controls the compression ratio. The second is, in concert with the transfer ports and also the exhaust ports, you can also affect how the swirl and the flow of gases in the combustion chamber happen to some level. Obviously, you also can optimize the location of the spark plug. Just all kinds of benefits by separating that, but you also now introduce a variable by having to have a gasket between the top and the bottom end. Yeah, I know the motorcycle motors are square versus over square. Otherwise, bore and stroke is usually pretty close to being the same, and that alters a lot of things. But the other thing, if you notice on the motorcycle engines, is because of that they also have a lot of blowdown. I mean, quite a bit of blowdown, and that's the difference between when the exhaust port opens and the transfers. We'll get into that another day. You know, very complex, very well thought out. That motor there was designed to have a very broad power band, where a chainsaw motor is not. I mean, there's just all kinds of design requirements that are different. But the funny thing is, two strokes are the same. The basics and how they work and how they run and how one variable affects the characteristics or the power characteristics is the same whether it's a motorcycle or a chainsaw. Another thing that you get with these separate cylinder head deals it's a subject matter which eats up an awful lot of time online, and that's control of the squish band, and therefore control of the what some call the squish velocity, and that's when the piston approaches top dead center. It has to squeeze this material from around the outside into the combustion chamber. Well, the motorcycle two-stroke guys have been playing that game for a long time. And if you look at the top of one of these pistons, you can see that it has a curvature, and they match the shape of the cylinder head to optimize that squish velocity to get as much of that material from around here, or much of that mix from around here, actually into the combustion chamber where it can actually be burned. The automotive guys figured it out sometime in the 80s. Two-stroke guys with the motorcycles, I think, had figured it out before that. But the whole concept with that is if you have too much distance between the piston and the squish band, there's a certain amount of material which won't be burned efficiently. In some cases, there's like this nasty distance where it's a little bit too close to actually burn, you know, but then it's not close enough to squeeze that material out. So to get the extra little bit of efficiency or power out of your motor, you take that stuff from in here that would not have been burned from the way that shape was because of how tight it was, and actually get it into the combustion chamber for that initial pop, and you get a more efficient motor as a result. The other thing you have to remember about motorcycle two-strokes is they're designed to run at a much lower RPM, and that also changes the way they have their port timing. You know, typically a motor like this would make horsepower from around 1,500 RPMs all the way up to about 6,000, 7,000 RPMs. You get around 9 or 10, you're just making noise. The entire power band was much lower in RPMs than a typical chainsaw. And again, I think I already mentioned it, but I'll mention it again. The motorcycle engines were designed to have a broad power band, and the chainsaw designs are, well, they're much smaller in displacement, obviously, but they're not as interested in having a wide power band as they are maximizing power at specific RPMs and being simple and being light, because you got to carry the damn things around, you know. And they have a much smaller space in order to achieve their goals than the motorcycles, where they have that whole frame and airbox and room for an expansion chamber and all that stuff. So totally different worlds. But moving on. The second thing I wanted to talk about a little bit is now that we've totally maligned the bottom feeder of the chainsaw world, the clamshell design, let me talk about the benefits. Because there's a lot of benefits. 90% of the saws sold don't get modified. And what's more important to the person who buys a saw like this is reliability. They want it to start and run every time, and go back to a dealer or to a modifier or to a person who works on saws as few times as possible. I think one way to think about this is you have one sealing surface and set of seals to worry about. Okay, two if you think the intake, where the so-called Pro Saw has the entire sealing surface of the cases. That's one, and that's a big one. Same seals. The sealing surface of the base of the cylinder to the cylinder itself. That's not going to happen. That's something a clamshell does not have, as well as the intake. So one of the benefits of the open port design is it's easier to manufacture. That's simply that's a more simple shape to replicate from part to part than these cast-in passages. It's just the way it is. And on the newer designs, they've tried to mitigate some of those potentials for variations by using these caps, because it's simply easier to manufacture that cap and use that to close the port or define the shape of the port than it is to cast in a core. So, hardest to manufacture, therefore you need a higher quality and higher capability manufacturing operation to do that, like Meili's been doing it, or Maul has been doing it for years and years. Very hard to replicate what they do. Much easier to do. Requires a little bit less manufacturing technology to achieve the same shape from part to part with this cap technology versus a cast-in core. But these are still easier. So when a design engineer, you know, thinks about a very simple and a very reliable saw, why not? It works. If you need more cross-sectional area for more power, just add another groove. The old home lights did that for years. And that, along with one-piece case like this, you've yet again reduced a lot of manufacturing variables as compared to something like this, where now you have to worry about the flatness of that mating surface and all kinds of things. So for a lower cost saw, you can achieve very, very reliable and very acceptable performance characteristics with these open port designs. And as a very good friend of mine likes to note, if you're out buying aftermarket cylinders and then recognizing the complexity of the manufacturing process for, you know, these type of things, to coin his phrase, it's a lot harder to screw these up. So in the aftermarket world, you have a greater chance of getting a good functioning cylinder with an open port design than you do with a closed port. But I'll let you ponder that one. In the 350 Husqvarnas, this was a cylinder from a 350 or a 353 combined quad port design with caps, and that was a pretty effective cylinder. It had one characteristic that made Husqvarna aficionados dislike it, and that's it vibrated differently and would vibrate the muffler off, but that has nothing to do with the port design, just something else altogether different. But anyway, I'm beginning to ramble, so I'm going to close this video off. I hope this information was interesting. Based on feedback, I'll expand on some of these subjects if there's a desire. So, talk to you later. Bye for now.